Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's session, we are going to discuss a numerical on the topic motion under gravity. Let's go to the numerical. A stone dropped into a well is here to strike the water after 4 seconds. Find the depth of well if velocity of the sound is 350 meters per second. Okay, so here the illustration of this numerical is given in the diagram. A stone is dropped into a well from a point, say A. From the point A, a stone is going to be dropped into the well. Okay. At point B, the stone is going to strike the water. So we can take the AB, the distance AB, that is the depth of the well. Okay. When the stone strikes the water at point B, it will create a sound, that striking sound. Then the sound will travel in all the direction and also in the direction BA. That means in the upward direction. And that striking sound will reach the point A, where from the stone is dropped already. Okay, once again I repeat it. From the point A, a stone is dropped into the well. At point B, it is going to strike the well. After that, it will create a striking sound. That sound will reach the point A, that means where the stone is going to be dropped. Here the AB is the motion of the stone. Point A, it is dropped. Point B, it is going to strike the water and it will create the striking sound. The BA, the upward motion, here, which one is shown? That is the motion of the sound. This striking sound of the water made by the stone, that will move in all the direction and also in the upward direction, and it will reach the dropping point A. So AB is the motion of the stone, BA, that is the motion of the sound. This total time taken at that from that instant of the stone is dropped into the well. After the striking sound to reach the dropping point A, the total time is given as 4 seconds. And velocity of the sound in this medium, that is also given as 350 meters per second. Okay. So here, we are going to calculate the depth of the well. That means the distance AB. Okay. This we can consider into two motion as mentioned here. AB, the downward motion, that is the motion of the stone. It's a free fall from the point A and will hit the water in the well at the point B. And it will create the sound here. BA is the motion of the sound. Okay, the striking sound. So these two segments, AB, BA, that we have to consider separately. In the motion AB, that means motion of the stone, If you calculate the distance in this motion AB, then that distance will be the depth of the well. Okay. So first here we are going to consider the segment AB. Okay, the segment AB, or otherwise the motion of the stone in downward direction. Okay, the motion of the stone in downward direction. So here we are going to calculate the depth. That means the distance AB. We know that S equal, it is a downward motion. So G, that is plus G. So it will be UT plus half GT square. Here T, what I'm considering is, that is the time taken by the stone from the dropping point A to B. Okay, time taken by the stone from the dropping point A to the striking point B. Okay, and here you can see at the dropping point A, it is freely dropped into the well, and hence its initial velocity u will be 0. So if it is 0, that entire first term that will be eliminated. So the depth or the distance AB, that means yes, that equal to 1 by 2 g t square. So that yes, we can write as 1 by 2, substitute the g value 9.81 or simply 9.8, whatever, multiplied with the t square. So if we simplify, we will get S equal to 4.9 t square. Okay, this is one equation. That means we got the depth of the well in terms of t. Here where t is the time taken by the stone from A to B. Okay, time taken by the stone from the dropping point A to the striking point B. Okay. After this time small t, what will happen? The stone will break or strike the water. Here it creates the sound. So the motion of the sound will move in all the direction and also in the upward direction, and it will reach the dropping point A. Okay. So here, next we are going to consider the motion of the sound BA. Okay. Here we are going to consider the general relation of the velocity, distance, and time. Here we can write velocity of the sound. Okay, velocity or velocity of sound. That is the depth of the well or the distance. Depth of the well, which we considered as S. Okay, divided by time taken. This time taken is the by sound. Okay, time taken by sound. Here we are going to calculate the time taken by the sound. Already we calculated, that means we consider t is the time taken by the stone from A to B. Here time taken by sound from B to A. So time taken by the sound from the striking point B to the dropping point A. This I mentioned as TS, or otherwise simply T sound. Okay, this one is the T stone, this one is the T sound. That equal to time taken equal to depth by velocity. Okay, depth by velocity of the sound. Here depth is S. If you know AB, that is same and equal to the BA. The depth we calculated already in terms of T. That means time taken by the stone. So the depth, that is S. Okay. Divided by the velocity, that is 350. This is the second equation. Now we know that the total time that equal to time taken by the stone from A to B. Okay, T stone plus T sound. And this one is given as 4 seconds. Okay, the total time is given as 4 seconds. From the dropping point A to strike the point B. Okay, that time taken by the stone, and from the point B to A, time taken by the sound. The total sound is 4 seconds. Okay, so the T stone simply has taken as T plus the T sound. We can substitute S divided by 350, that equal to 4. And S equal 4.9 T square. Then substitute it. Okay. T plus 4.9 T square divided by 350, that equal to 4. Okay. Then we can write this equation as 350T this side, 350T plus 4.9 T square, that equal to 4 into 350. That means 1400. Okay. By rearranging this equation, 4.9 T square plus 350T minus 1400. Okay. That equal to 0. This is in the form of quadratic equation. Okay. Then we have to calculate by using the quadratic equation. Okay. I just write the equation here. 4.9 T square plus 350 T minus 1400, that equal to 0. Okay. Here we have to find the small t. Then we can find the depth of the well. Okay. To find the value of t, we can use the quadratic equation. How to solvation procedure of the quadratic equation. That means the roots we can solve by using the formula minus b plus or minus under root of b square minus 4ac divided by 2a. So by comparing the equation, a that equal to 4.9, b equal to 350, c equal minus 1400. Okay. Then substitute all the values. Minus 350 plus or minus under root of b square, that is 350 square minus 4 multiplied with a, 4.9 multiplied with c, minus 1400. I am going to put this minus and minus is plus 1400 whole divided by 2a. If you calculate this, we will get 2 roots for t. That is the roots of this quadratic equation. Here one will be the minus negative root and another one will be the positive root. By simplifying this and neglecting the negative root, then we will get the positive root that equal to 3.8 seconds. Okay, this is the t, that is time taken by the stone to reach the point B from the dropping point A. Okay, and we know that we discussed that equation 1, that is S, depth of the well, that equal to 4.9 t square. Okay, now substitute the value of t in this equation. So we will get S equal to 4.9 multiplied with 3.8, then square. So the depth of the well S equal 4.9 multiplied with 3.8 the whole square, that is 70.8 meter. So this is the required final answer. That is the depth of the vessel, depth of the well. Okay. Once again, I just repeat the numerical. From the point A, a stone is dropped into the well. At point B, it is going to hit the water. That is the motion of the stone. The striking sound, which is created at the point B, that will move in all the direction and also in the upward direction. Then it will reach the point A. Okay, here AB is the motion of the stone, BA is the motion of the sound. This 4 seconds means from the dropping point A to B, the time taken by the stone plus from the striking point B to the dropping point A in the upward direction, the time taken by the sound. Okay, that total time, that is 4 seconds. So for that, first we considered the motion AB, S equal ut plus of at square of gt square, that formula. Here it is freely dropped at the point U, that equal to 0. Okay, if it is freely dropped, then the initial velocity equal to 0. Then we got the value S equal to 4.9 t square. Then BA, that is the motion of the sound in upward direction. Velocity of the sound equal to depth of the well divided by time taken by the sound. So time taken by the sound from the striking point B to the dropping point A, that we can write as depth by the velocity. The depth, if you consider the distance AB, S divided by 350, velocity of the sound. The total time, this 4 seconds, that equal to the time taken by the stone from the point A to B plus time taken by the sound from the point B to A. So that equal to 4. Time taken by the stone we consider as small t plus time taken by the sound, that is S divided by 350, that equal to 4. Then by simplifying, we will get a quadratic equation. Then by solving the quadratic equation, we got 2 roots for the time. By neglecting the negative root, then we got the positive root, time equal to 3.8 seconds. Substitute this value in the equation 1. which is equal to the depth of the well, that is 70.8 meters. Okay. I hope you all understand this numerical, what we discussed in this video. And guys, one more thing, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver, because further upcoming videos, we are going to upload and discuss many numericals on motion in straight line, motion under gravity, D'Alembert's principle, connected bodies, laws of motion, okay, etc. etc. So don't forget to subscribe. Thanks for watching. Once again, thank you guys.